Table 3 wants to volunteer for number 7. Go ahead. So 7 squared minus 7, 49 minus 7, that really is 42, so he is correct. He can have a point. Okay, Karen, you were volunteering. You already asked to volunteer for number 2, or whatever it is, number 8. Didn't you say you wanted to?
Yes.
Okay. You got an answer of 4? Okay, let's see. 10 minus 2 plus 2 squared is 10 minus 2 plus 4, which is 10 minus 6, which really is 4, so you have a point. And this is where all the points are going to come out today, number 9 and number 10. Can someone tell me the x-intercept? Okay, she was fast. We'll give it to her. We'll just say 4, but she is correct that this point down here really is 4, 0. Okay, and then the y-intercept, you can have a point. Yes, dear? Yes, dear, you can have a point. And I'm just going to put it at 3, but yes, you're right. The ordered pair is 0, 3. And this is where life tends to get a little bit bumpy, which is sad because you already knew this. Can someone tell me the equation of a line in slope-intercept form?
I know we do y equals mx plus b. Right?
And you can have a point for that. And I can tell from my graph that the b is at 1, 2, 3. So I know it's y equals something. I got to figure that out. X plus 3. But now to figure out that something, how can we figure out the slope? Say what? And your group gets a point for that. You want to tell me how you did it?
I just found the next point.
Did you calculate it or did you count?
I counted.
Okay, I count too, but I'm going to do both.
Okay.
Okay, right, the slope is rise over run. What does that mean? Which way do we go? Up or down first, or left or right first?
Flip it around first. Not right.
It's white. It's up and down. So rise. So it makes sense that we're standing up, over run. So I'm going to count how many up and over from those 2 points we were just discussing. I went up 1, 2, 3. I went over 1, 2, 3, 4. So I went up positive 3. I went to the left a negative. Since you're going to the left, it technically is a negative 4. So my slope is negative 3 over 4. That's the easiest way to do it. However, if you're one of those formula people and you love your formula, you could always use that handy dandy slope formula, the m equals y2 minus y1 over x2 minus x1, which is going to slow you down, but maybe worth it to you. So 0 minus 3 over 4 minus 0, and I still get negative 3 over 4. Either way, I get negative 3 over 4 for the slope. You can count it, or you can use a formula. And that one actually didn't go as train wreckish as I imagined. Let's pray the next part doesn't either. Can someone tell me standard form? Yes? That was going to be my hint, was there's an A. It starts with A. I don't know. So you think it's AX and then what? You were so close. You were so close. Okay, AX plus BY equals C is standard form. So we have some options, since most of us did not instantly remember that one. The easiest thing is probably just to rearrange our equation. So we had it in slope-intercept form. And if we're looking at standard form, the difference is, let me zoom in on that. If we're looking at standard form, the difference is we have the X and then the Y and then the equal to sign, and then the number on the other side. So right now I need to move over that x because I need it to be the x piece, the y piece equal to a number. However, your algebra teacher would be so mad at you if this was your final answer, because in standard form you're not allowed to have a fraction in front of the x. So we're actually going to multiply everybody by 4, and we'll end up with 3x plus 4y equals 12. And that will be our final answer. Stop shaking paper. I've got to know it. And then if we were being super smart, we might notice that there is a correlation with standard form and those x and y intercepts. The x-intercept is the same number that's in front of the 4. The y-intercept is the same number that's in front of the 3. So maybe we should have been able to get to standard form without doing this equation rearranging. But whoa, Miss Compton's getting really deep this morning. Let's keep it simple and move on. I swear we're reviewing this because we're eventually going to get to it. That's probably what's going to happen next chapter. Makes sense. We've done all the basics now, so we're going to get to actually graphing things. I'm going to be real sad if you don't remember x-intercept, y-intercept, slope-intercept form. I'm going to be less sad if you've forgotten standard form. But if you don't remember slope-intercept, oh my goodness. Chapter 2 is going to be a bummer for you. Okay. Number 10, the x-intercept. Okay, let's give, you got points out the wazoo. Let's give table 5 the point. What are you at, like positive 7 already? You only have 2? You can have a third point. Y-intercept. Oh, that was a whole lot of people. I don't even know who to get the point to. Okay, and then we've got to write the equation of the line and slope-intercept. The person who gives me the equation of the line and slope-intercept will get the point.
Y equals negative 5.
Say yours again.
Y equals negative 5 over 5, x plus 5. What is negative x?
And then you say yours.
So 1 plus 5.
Okay, you can both have the point. Okay, the answer is y equals, and then we normally are questioning the slope, and then x plus 5. Paige counted, I assume. She went up 5 and over 5, so 5 over 5 ends up being just 1. That's why the slope is 1. So do we normally write it? No, we would just write y equals x plus 5. Or maybe, since Paige was telling me some negative things, I think she calculated it. So she knew this was at negative 5, 0. She knew this was at 0, 5, 0. She probably did y2 minus y1 over x2 minus x1. And she got negative 5 over negative 5. And that's how she got positive 1. That's what she knows. Daniel and I just counted it. And then for the last point, from the math workshop, what is the equation of this line in standard form? Nope. There's one more thing I should probably tell you with standard form. You can't have a negative a value. Equals what? You can have your point. Okay, the answer is x minus y equals negative 5. For those of us who don't know how you got it, let's go over it. So it was like this in slope-intercept. He subtracted x from both sides and had negative x plus y equals 5. But you heard me say that we can't have a negative a value. So he multiplied everybody by negative 1. And he got x minus y equals negative 5. Again, let me reiterate. If you've forgotten about standard form, I can forgive you for that. That's why we're reviewing it with these math workshops. However, I cannot forgive you for not knowing slope-intercept. I cannot forgive you for not knowing x and y intercepts. Okay, yesterday we were doing notes. We got to finish up the last 4. Go ahead. If you hadn't gotten that out already, get it out. I see at least one person still writing, so let me use words. If I did not check your homework yesterday for whatever reason, you could show me that. Some people still haven't passed that tiny blue latest checkpoint. You could show me that in a few minutes. If you've already done your first workbook assignment, you could show me that. There's a new workbook assignment today. It's on page 12. It's numbers 9 through 16. If you got that done, you could show me that. Seriously, Miss Compton only has 4 problems to do, and then she's done teaching you new things. That's it. Tomorrow is review. Friday is the test. There was someone in a different class period that's already worked the study guide. Is that necessary? No. You have all class tomorrow. Was it smart? Maybe. That way she could go ahead and ask me. She was having issues with the last 2 problems on the study guide. So if you have your 1-6 notes, the last 2 problems on the study guide she couldn't do. And I said, well, yeah, baby, that's what we're talking about in class today. So, but I was really impressed. You do not have to do that. You do not have to be that person. I'm just letting you know that it's not a terrible idea. Okay, yesterday we were doing problems. We did 1 and 4, and we did 2 and 3. And on 2 and 3 we were very specific. We put the word or. On 1 and 4 we didn't put any words, but if we were to go back in time and add words, I would say these are and problems. So if you end up shading in the middle where they meet, it's an and problem. And if you end up having the 2 ends, the 2 extremes, it's an or problem. Just so you know in case you see that in the future, and yes, that is going to come up today. Last checkpoint. A lot of people hurt my feelings again. We're still struggling with absolute value, and sadly it's showing up again today. So as a reminder, if this problem was absolute value of z equal to 8, we would say that there are 2 answer options. One where the stuff inside the bars equals positive 8, and the other answer option would be where the stuff inside the bars equals negative 8. Just a general reminder, with absolute value problems, there should be 2 answers. Okay, so things look the same, except today we have that inequality in between. There's still going to be 2 answer options. One is still going to involve z and an 8. The other is going to involve z and the negative 8. That part stays the same. In fact, the first one is completely normal. All Will is doing, there's no Will in here, all Jax is doing is dropping the bars. He says, okay, drop the bars, z is greater than or equal to 8. The issue with absolute value happens with that second answer option, the negative version. You actually need to flip that inequality. So again, what I've written in a different color is the new thing that we need to keep in mind today. Yes, there's a positive version and a negative version. On that second version, you have to flip the inequality. Okay, so if we had to solve, we would still solve, but thankfully this one's already done for us. I'm going to make it pretty and put it in a box later. I'm going to go straight to that number line now. I know I need to have negative 8 on my number line. I know I need to have positive 8 on my number line. And I'm getting kind of lazy. 5, 4, 3, 2, 1, 2, 3. So I'm just going to put a bunch of dashes in between and we're feeling like it's enough. It's not. No. If you do a stinky number line like mine, I own the test. I'm not going to be mad. As long as it's legible. Okay, so I'm supposed to put a circle at -8. I'm supposed to put a circle at +8. Let's focus on this one first. The first option, z is greater than or equal to 8. Do I fill in my circle? And you can have a point. With a z greater than or equal to 8, which way do I shade? Which way do I shade? With z greater than or equal to 8, which way do I shade? To the right, and you can have a point table too. And then with z less than or equal to -8, less than means you shade to the left. And now our answer is reminding me of number 2 and 3 from yesterday with those 4 problems. So if I were to go back and make a pretty answer that I could circle, I would say z is less than or equal to -8, or z is bigger than or equal to 8. Are there any questions about this problem? Tylen's going to miss it if she doesn't get 2 answers with her absolute value problems, because not only has she messed up the answers, but then she's also messed up her number line and her graphing set, graphing the solution. Okay, so we go to our second problem. Still going to have 2 cases. I'm going to have 4t minus 3 is less than or equal to 7. But with my second case, I'm going to have 4t minus 3, and I have the -7, but I've got to flip that inequality sign. So it was less than or equal to. I'm going to make it greater than or equal to. Are there any questions about this part? Did I make it 4t plus 3? Did I change anything inside those bars? I just wrote down what was inside the bars. 4t minus 3 was inside the bars. I wrote it down both times. The only thing I'm changing signs on is the 7. I do a version where it's positive and a version where it's negative. And on that second version, I flip my inequality. Okay, well, we can't graph that. We've got to get t by itself, so this one's going to require a little effort. Points to whoever tells me the answer. With which one, maybe? I get greater than or equal to -1. Thank you, dear.
Is the first one 2.5?
I want a fraction. Do what? Why do I flip?
I got t is greater than or equal to
Same. But with the first one, what should I get?
t is less than 5.
Okay, and table 2 can have the point. I get that decimal is 2.5. I get it, but Miss Compton likes fractions. Okay, I'm not going to add the word or yet. I'm going to go ahead and graph it. See what my life looks like. Okay, I'm getting super lazy with my graph. So I know I need a -2, a -1, a 0, 1, a 2, a 3, and then I know I'm done because Angel already told me 5/2 is really 2.5. So I know this is 5/2. I also know I need to put a circle at -1. They're still going to both be bubbled in because it's both less than or equal to and a greater than or equal to. And then when I shade, where am I shading? So -1 to the right. Ooh, I'm shading -1 to the right and I'm getting a little nervous. I feel like I'm going to run into that one, so I got to go look at this one. It says less than, so I was supposed to shade to the left anyway. So is this an OR graph? No, it's not one end or the other end. It's the middle region, so we would call that an and. So if I'm being politically correct, I can go back and add that word and. Or And now if Tyler doesn't do this on the test, I'm not mad. I get life is hard. I'm just telling her all the things. Or if I got super fancy, I could make it into one giant statement. I could say t is bigger than -1, so -1 is less than or equal to t, but t is less than or equal to 5/2. Now, if Tylen doesn't have what I have in pink on her test, I am not mad. As long as Tylen has the work and the graph, she's good to go. I just want her to be able to read this for the future. Okay, are there any questions on number 6? Then let's go to number 7. For a point, can someone tell me my 2 options? And my other option? And you get a point. Okay, go ahead and solve, and someone tell me what they get for the first one. What'd you say? Did you say it first, Ellie?
B is good.
That's what I thought. And, I mean, Justice was on it, but you said it first. You get the point. And then the second one, you know I'm going to want a fraction, so do not decimal me. And you get a point. So I've got 3v is less than -19. I divide by 3. I have v is less than -19/3. For those of us who just can't stand it and have to know, the decimal version would be -6.3. But I'm looking for that fraction. Okay, again, I'm not thinking about whether this is an and or an or. I don't even think about that until after I do my graph. I know I need a 3 on my graph. And I know I've got to go bigger than -6, so. My graph got a little ugly there on the end, but it's okay. Okay, I know at 3 I put an open circle. I know at -19/3 I put another open circle. If I could redo my life, I swear I would extend my line. Have some extra stuff going on. V is greater than 3 is shaded to the... Can you just tell me, is this an and or an or? And you can have the point for that. So we shade to the right for V is greater than 3. We shade to the left for the -19/3 is less than. And we end up getting an or. So if I rewrote my answer, it would say V greater than 3 or V is less than -19/3. Are there any questions on number 7? Then we get to my favorite number of the day, because it's the last one. Number 8. $2 points for Dax. Number 8 is actually my favorite because you can't do anything on it. Do I want Cooper on every single problem on the test put no solution? All my bad words, no. No. No, 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 no. But Jack's already said why this one is no solution. Because we end up having the bars are less than a negative number. Is there any number I can plug in that's going to end up making this less than -1? No. If you plug in -7, for instance, is +7 less than -1? No. Whatever you plug in, it's going to turn out to be positive. And a positive number is never going to be less than -1. So it is no solution. Now, should you be weary in life? Because if the problem was it's greater than -1, that one might be more feasible at least. Because, I mean, so if we plugged in that -7 again, we ended up getting +7, so -7 at the end. Well, +7 is greater than -1. So there are a lot of numbers that would work for this, but there are some numbers that wouldn't. No, all the numbers would work. So we would actually have to think it through. Jack thought through, like, hey, no matter what I plug in, it's never going to be less than -1, so it's no solution. If there is a no solution when on the test, if I notice it in advance, which we pray I will, I should. I swear I will say when I pass the test out, P.S., there's a no solution problem. Does that mean I won't tile in on every single problem to put no solution? Heck no. Just one. Just one. That's it. Okay, you have lots of things to work on. Just because I'm done rambling does not mean that you don't have math to do. You do. I will gladly add and take away points. I had to take away points like